Alright, we're back. We're starting another OSPF lab. It's day 27 lab. So, see how this goes. So, for some reason, the font didn't save all my settings. So that's fun. Packet Tracer had me log in again too. So, not really sure why. But okay, we'll go to preferences and we're gonna change the font. Maybe it didn't. I don't know. Let's make it bigger. Doesn't seem to change it. Let me zoom. I guess we'll zoom. That'll work for now. So the first step is configure the host names. I'm really not gonna bother doing that again. I mean, come on, it's just absolutely, utterly tedious. So we're just gonna say done on that one. I'm gonna have to look this ridiculous thing up here to why this freaks out like that, but it's number 2, configure a loopback. So let's go ahead and do that. Router 1, loopback. For some reason, I don't know why these all say router PT empty. I'm in the other Windows profile and I loaded the same packet tracer settings in there so that I didn't have to reconfigure everything, and it shows that it doesn't seem to break anything, but if somebody knows of a fix, let me know. Otherwise, maybe someday I'll look it up, but probably not. So, loopback. This time, we're going to use loopback 1. No, loopback 0. Last time we used 1. So, okay. The address 111 255 255. A minute. /32. So you actually do the full thing. That's, I guess I don't get that, but maybe we'll pull up the old manual here. So let's look for loopback. You know what? We'll go back. Nope, can't click on it. Sorry if my breathing is loud. Hopefully OBS takes that out, but you gotta breathe, so I can't really stop doing it for the video. We'll throw some music on there anyway. Plus, if you're trying to fall asleep to this, it should be relaxing in a way. Try to speak in a relaxing way. So, talking about clock rates on routers. Not interested in that. Back. So, maybe we'll do a bit of ChatGPT. That guy up there. So here's what we'll do. I'm gonna minimize this. And just gonna take a screenshot using my mostly favorite tool, Greenshot. Highly recommend it if you haven't used it. least the Windows version. There is a Mac version. I think they charge for it on the Mac, but it's alright. It's not as good as the Windows one. Sorry, my voice is kind of weird today. I do wish that they would add a timer in there, like with the snipping tool. You can set a delay for your screenshots. That for whatever reason they haven't included that in screenshot. So anyway, we're in ChatGPT. We're gonna say why is loopback. Have that explained a little bit here. Nothing like watching somebody else chat GPT something, huh? But you're probably not even watching. In fact, right now you're probably drifting off to sleep. So, yeah, I don't know, the whole sleep theme here. I kind of figured nobody's gonna be interested in watching this. I tried to edit. I edited the first video, went alright, but the second one was just was tedious. It was nice. I learned DaVinci Resolve. I mean, got decent at that, but you know, I want to learn. I don't want to spend forever editing. So maybe someday I'll get an editor, or I'll have time if I actually ever get people watching this, perhaps. But so anyway, back to this, the loopback. It's not a physical subnet, it's a logical interface. It has a host-only address, the router. So yeah, alright. Guess I don't really understand loopbacks that well, obviously. I guess I don't know the scenarios of why you would want to use one. Doesn't seem like the book explains it. I mean, maybe it does. I'm obviously not reading the whole thing, but I'm doing a search and doesn't seem like it explains a lot. You know what the issue might be. Let's go back home. Isn't there several books, like part 1 and part 2? I wonder if that's what's going on. I swear there was. Wasn't there in the other video? Wasn't I clicking on like part 1, part 2? I swear I was. So how do we find that? So is this volume 1? Okay, so where's volume 2? I just search. No. So for some reason, dare I open this thing in Adobe? Dare I do that? I really don't want to. Adobe is so annoying. It continually prompts me to make it default, even though it's not even open. I had to tell it to stop sending me notifications. But yeah, there we go again. You can't see it, but it's asking about default. So here we see volume 1 and 2. So why can't I find this here? Volume 1 and 2. Here, you know, page volume. Oh, I wonder if we could do volume 2, 0, 1. Or maybe just some sort of setting. Let's go 100%. What's it? Oh, that's why it's at 200. You know what is going on here? Show. I don't know. Sometimes it's like just the simplest things can be complex, you know. Let's work in an IT for you, though. Go to fix a problem, and you find you're spending an hour fixing some completely unrelated thing that you need to work in order to fix your problem. It's kind of like if you're in construction and you need a hammer, but your hammer just, you know, melts like a piece of rubber and something hot. I don't know. Bad analogy. But it's kind of what it's like. So. Chapter. I know. Let's try it. You know, I've decided to stop apologizing. Well, I shouldn't say completely, but for taking a long time or whatever. That's just how it's gonna be. So. So let's look here. Okay, let's. Let's see what this does. Good old ChatGPT. So it's a library. No, I am quite sure it did have that. I don't know. I thought it was in the same PDF, but maybe not. We're gonna have to figure this out though, because I want to reference this book. So we're on chapter 26, volume 1. So what if we scroll down here? Still volume 1. Man, this is long. This is a lot of stuff. Chapter 9. This must be volume 2. I swear though, before on the left there was in the menu something we could click on. When I say we, obviously mean I, but theoretically somebody might listen to this at some point. So there's volume 2. Alright, so really, I guess, searching for Loopback. So here we go, we're talking about it. So Cisco uses it to meet an exact need. Send a packet to router 3. It's not tied to the state of any one interface. That is, NTP should work as long as there's some path. Okay. So, even if a particular interface goes down, as long as we can reach it, we want it to not break. We get that. So they're virtual interfaces. I'm trying to move the mouse here around where I'm reading. So let's look at this one. Base loopback number. Once configured, exists inside the router. It's not tied to any physical interface. So we assign it an IP. And routing protocols can advertise about the subnet. You can ping traceroute that address so it acts like physical. So see here, it's a /24. So in the lab, it's a /32. So I guess I don't get why that would be. So, so it seems like there'd be no host part, the IP. So, I guess today we're learning about loopbacks, is really what this video is. So, it's not really about the OSPF Lab. We're gonna learn about loopbacks today. So why would we use a /32 for loopback? That's a question that we're gonna tackle here. At least why in this lab do they want us to do that? So on a normal interface, the mask defines the network portion and the host portion. Okay, because there's multiple devices on that subnet. On a loopback, there's only one device, the router itself, so there's never going to be another host. It's this single IP. So there's no broadcast domain. Because obviously there's no broadcast. Let's get paint going. I have to draw. Oh. I'm gonna have to really start sharing like more of my screen so I can draw while we're doing this. I wonder if I could do that now. Let's see. Display capture. I don't even remember how I set this up to only show that the right portion. But it would be helpful if I could show the right half of my monitor. But again, we're kind of getting off into the weeds again. But it would be helpful. So let's see, I'm going to turn my display capture off for a second here. I'm going to look at the properties. Oh, could we? Suppose I would maybe need to adjust the resolution or something. Ooh, that was... Yeah, I don't know what the resolution would be. So, something to tackle in the future. So getting back to this, do a small little paint here. So we'll get this GPT over. So on a normal interface, you have a mask and a network. But on a loopback, there's only one IP. So you assign it /32. So OSPF advertised this as a host route. Okay. So it works for router ID and management, or stability, basically. So if we look at a router, I thought that was going to draw a circle, but apparently not. Let's find a circle. There we go. So we put an IP as a loopback. If where's the little draw thing? So let's say we have 192.168. No, actually we're doing. Now wait a minute. Hold on. We're assigning 1.1.1.1. Why would we do that? That's not an RFC 1918 address. So that seems weird. Is this just something in the lab? That seems odd. Let's find out. Is it common? Assign this. Yeah. It's not an RFC 1918 address. Oh, look at that. Apparently that's an important detail. And Cloudflare owns that IP. So in practice, apparently people use that for whatever reason. Easy to type. So it's easy to type, yet the first one is assign host names, everything, which is extremely tedious. I get it. I mean, I understand. But I guess my critique of that would be it could be confusing. So if you're really trying to understand this, it'd be helpful to know that you would assign obviously an address like that, because what made me think of that was, if it's advertising this route, OSPF advertises that. It says, hey, buddy, neighbor, I've got a route here. Come to me if you want to reach that guy. But it's an internet address, so that would cause a problem. So that's why I got thinking about that. But that kind of helps at least me to understand it better. So really we'd use like 192 blah blah, and then let's say 10. We'll say 192.168.192. There's got to be a better way to draw than this. This is terrible. If I could use my iPad, that'd be great. Say .1. So there's our network. But it's not a network because it's a loopback. So OSPF is going to advertise this out, so that way we can always reach it. But this goes back to a deeper fundamental question. There's no network and host split So I guess I'm confused by that. I thought we always had to have, like, even the smallest IP range, dot slash 30, dot 252. Or is it dot 254? No, see, you can't have slash 31s, as far as I understand. Let's just confirm that. Because there's only one address. Oh, interesting, you can. See, these are the things I don't know. Slash 31 leaves 2 IPs total. So, let's see. Slash 31 just leaves 1. Then, if we have 1, 2, 3, 4, 5, 6, 7, 8. We're gonna look at the binary here. Oh geez, come on. There we go. Let me erase this. So we look at the binary. So we have like 128. Boy, I gotta get a better way to draw, because this is terrible. It would be really nice to draw. Too bad Apple doesn't let you do that. I mean, maybe I could record this on my Mac in the future. I don't know. I don't want to have to, but alright, so 64, 32. I'm gonna do some things here with a binary. 16, 8, 4, 2. Okay, so I was wrong. It's not 1, it's 2. I should have known that. I just wasn't thinking rightly about that. So yeah, so there's 2 addresses. And normally you need 1 for the network and 1 for the broadcast, leaving 0 usable hosts. So apparently there's an RFC, a modern rule. It's valid for point-to-point links. Because there's no broadcast concept needed, so both addresses usable. I suppose then maybe you take it one step further then to loopback. So let's ask about that. So with loopback, let's take one step further. Okay, so we nailed it. ChatGPT is so positive. So there's no, so I get that. But if that's the case, is it in the RFC? So let's see if we can look at the RFC. It's not formalized in in an RFC. Interesting. So we can do /31 for point-to-point links. And I get we're using a similar concept for loopback, but so there's no RFC that authorizes it. It's used for things like this. Okay, so I get that. We get that here. Hopefully we get that. At least I get it. My question is, how does it work then if it's not formally defined in an RFC? all 32 bits are in the network portion. Leaves exactly our address. Okay. So the router injects it into its router information base. I guess, would that be called the routing table? I think. Could be wrong, but. So, okay, can be distributed. So why do I need an RFC? Because it's not a special invention. Interesting though. So, if there's no broadcast address. Okay, so there's no broadcast address because we don't need to broadcast anything. Point of a broadcast address is to, I mean, by nature of the fact that it's a broadcast would indicate there's multiple hosts. Though in /30 there's not really. So, but let's just not worry about that. How would you, wouldn't you need a default gateway then if you're going to another network? Or does it act as its own default gateway? I suppose it acts as its own. So let's say you have, there's got to be a better, what is this? There's got to be a better program than Windows Paint can use, but maybe Microsoft Whiteboard, I don't know. Some point we'll deal with that, but so thinking about this here, let's say you have a firewall. Right, I'm gonna draw classic, firewall there. That looks pretty good. And on your internal interface, you have 192.168 blah, say 0.1. That IP is assigned to your internal interface. So that means this guy doesn't have a default gateway, because this guy is the default gateway. Let's say we have a bunch of computers, and they're .3 and .13 and .27 or whatever. They have their own routing tables. It's a routing table. And they also have their own default gateway. And that default gateway is .1. So, not only do they have their own routing tables, but, well, and of course we have a switch in the middle here. Boy. By the end of this, I'm going to get really good at drawing in Microsoft Paint. Mouse. Probably ways I could do it better. Maybe increase sensitivity or something. But anyway, so if they want to get out past the network, obviously they get to this guy, and this guy's got its own routing table, and he sends the traffic out. So, thus, this guy doesn't need a default gateway because the routing happens internal in the firewall, and it knows, hey, if I want to get to, let's just say 2.2.2.2, or whatever, let's say that network, just for heck of it. It says, this network, oh hey, I know I'd go out this, I don't know what IP to use, we'll just say 199.21.3.17. In the routing table, it knows, well, this network is directly connected. I'll just say it's /24 just for simplicity. But switch shows directly connected. And this firewall has its own default route. Default gateway, or default route, I guess. So yeah, the firewall's got default gateway on this interface. And this guy says this 192.168.0 network is directly connected. So it knows, okay, if I want to get to this network, we go this way. If I want to get to this 199 network, we go to this directly connected one. Otherwise, I don't know anything else. So we go out this way. And this guy will have its own default gateway. .1 or whatever. The ISP or whatever thing is next. So that was convoluted. But that brings us back to Loopback. I don't know, I highlighted that, but Loopback doesn't need a default gateway because router has routes. It has its own routing table or rib or fib. So if we go back to our famous IP here, this router is sending out LSA packets or advertisements. I assume they're packets, but it's sending out LSA advertisements saying, hey, I've got a route to this guy. So if we're just sitting here on our little computer and we want to manage this router, rather than, oh, I'm going to use this interface IP or this interface IP, we can just use the loopback IP. So when we SSH into it or what have you, we just do this, and we know how to get there because while this guy is our default route, this guy knows how to get there. Or if we're over here on this network, same thing. This router knows how to get there. Getting back to the scratch my ear there. So getting back to the let's make this GPT a bit smaller even. That doesn't even let me. Oh, there we go. So getting back to the broadcast thing, we have PC switch. There is going to be certain types of traffic that is broadcast traffic. There's also unicast, multicast. So broadcast should go to everybody. Unicast should go to one, as far as I'm aware. Multicast goes to a special IP, like, what's it, 224.0.0.5? Is that OSPF routers? I don't know if that's it, something like that, but I believe that means anything with OSPF that's running, when it sees a packet come by destined to that IP, and be like, hey, I'm gonna grab that. This guy likes it. He's got a Now, whether this actually is all OSPF or not 100% sure on that. But the concept applies. Whatever thing you're running, if you might be looking for multicast traffic to that particular multicast IP, and you might grab it. You know, this guy's gonna grab it. This guy's just cranky. He doesn't want to grab it because he isn't running OSPF or something's broken. He's just having a bad day. So we'll leave him alone. But okay, so that's loopback interfaces. So if we go in and look, we go in and look at show run, we see we have a loopback. We're configuring it with Cloudflare's IP. Not confusing at all. So we're gonna make same thing here. Interface loopback 0. Notice that the state changes to up because it didn't exist before, as far as I'm aware, and now it does, and it just kind of changes it to up. So now we're going to go IP address 255. Now we know why we're doing that. Write the memory, and we're also going to put the memory here. Oops. So I guess maybe we'll call this one good. Because we finished number 2. Well, they do say do it on each router, etc. I don't want to bother with that right now. We learned the concept. Maybe at some point we'll deal with that. It doesn't seem to me like the rest of the lab needs it, but well, maybe it does. But we're certainly not going to get through the rest of the lab tonight. So, oh boy, this thing. Somehow you're watching this and you know why this thing does this. Let me know. Because it's a little annoying. But I'm not going to spend time on that rabbit trail. We've done enough rabbit trails for tonight. That's all we got. Talk to you later.